In this lesson, we're going to start off with reviewing some formulas from middle school for area and perimeter of polygons and also for circles. So the first thing here is when we're talking about perimeter, perimeter just means that you're adding all of the sides. It's the outside. So if you think about a field with a fence, perimeter would be the fence. So it's the adding all the sides. So for all of these perimeter formulas, if I have a square, I'm just going to add up the four sides. So for perimeter, I'm just going to say add all sides. And you can think of different formulas. You could say s plus s plus s plus s or 4 times s. But really, anytime I'm thinking perimeter, I'm literally just going to think I'm adding up all the sides. So instead of writing a new formula for each of these, let's just say we're going to add up all the sides. So same thing with the parallelogram. You're going to add all sides. Triangle, same thing. So once you know all side lengths, you add them up. Trapezoid, again, same thing. So no matter what, we're going to be adding up all of those sides. And then for circle, you're still finding the perimeter, the outside of this, or the crust of a pizza, but the difference is we call it the circumference. That is going to be a little bit different because there's not really sides that you're adding. So instead, we have our circumference formula, which actually is given to you on your reference sheet, which is nice. So circumference is either written as 2 pi r, so the r being the radius, or just pi d, meaning the d stands for the diameter. And the reason why you can substitute those is because 2 radii equal 1 diameter. So in the end, these are the same formulas. It's just depending on which, if you have the radius or the diameter given. And then just so you know, whenever you see the pi symbol in a calculation, you're going to be using the pi key in your calculator. So make sure that you're not just using 3.14, you're actually typing in using the pi button on your calculator. So we don't want to round until the very end. So that's it for perimeter. You'll see more with that later. But the next thing we're really going to focus on is area. And area, the formulas are not going to all be the same. They're going to be a little bit different. So when we talk about area of a rectangle or square, these two are going to be the same because essentially what you're doing is you're just multiplying the length times the width, or you could say area equals base times height. In the end, you just have to multiply the two dimensions. For a square, you could also say area is equal to the side squared because the two sides are equal. Any of those would work. Same thing for a rectangle. You'd have length times width or base times height. Essentially, multiply the two numbers. Up to you. But the side squared wouldn't work because in a rectangle, the two sides are different. So just be aware of that. When we talk about a parallelogram, it's going to be this. It's going to look the same as what we use for a square and a rectangle. But the difference is the fact that when we talk about a square and a rectangle, we're just multiplying the two sides because there's a right angle. That one dimension is serving as the height, and then the other dimension here is serving as the base. When we're talking about a parallelogram, the height has to be perpendicular to that base. So notice we have this other side here, this slanted side. We're not using that. We're using the base, and then we're using the height, which has to be perpendicular to the base. So that's going to be important. But if you really remember that these formulas are all the same, then it's really just one formula to remember for all three. But just remember, height should always be perpendicular to the base. And then when we look at our triangle, again, what I just said, height should always be perpendicular to the base. So you have to know your base and you have to know the height for this. A triangle is really half of a rectangle or half of a parallelogram. So that means your formula is just going to be base times height over 2. Or some people like to say area equals 1/2 base times height. Again, these are both equivalent. So in the end, if you just remember that a triangle is half of a square, rectangle, or parallelogram, well, that's where the formula comes from. And then a trapezoid is unique because there's two bases in a trapezoid. So what I'm going to do is I'm going to switch these letters. I'm going to say that this is B1 for base 1, and this is going to be base 2. Typically, that's how you're going to see the formula written. So if I call that base 1, this is base 2, I have to consider both of those bases, plus I have to consider the height. And again, the height has to be perpendicular. So when we talk about area, it's going to look very similar to triangles. So it's going to be base times height, but we have two bases, so we have to add those together. So it's going to be, let me fix this, base 1 plus base 2 times the height over 2. So see how it looks very similar to the triangle? The only difference is this has just a base, because there's only one base. Trapezoids have two bases. It's the two sides that are parallel are our bases. So the other way that you could write this is 1/2 base 1 plus base 2 times height. Again, it's a preference thing. It's whatever you prefer. They're equivalent to each other. This formula is not given to you on your reference sheet, so that one you will want to remember. And then the last one is circle, and this is kind of the unique one. So it's pi r squared. So you're squaring, think about area, you square your units, it's 2 dimensions. So you are going to square that radius versus perimeter, you aren't going to be squaring. So same thing when you do perimeter, you keep your units the same, it's 1 dimensional. So that is kind of how you can remember which one's which for the circles. So if we go ahead and we start looking at how do we apply these formulas, we are going to see problems both on the graph and in plain space. So you'll see some different ones in your practice. But just to kind of start here to preview this a little bit, this first example just says find the area of this trapezoid. So there's really like 3 different ways I can go about finding the area. So one method would just be to use your formula. So just use the formula. And the reason why I can use the formula is because looking at this, everything's countable. It makes it easy. So the formula for area is base 1 plus base 2 times the height over 2. And base 1, I can just count. So that's 1, 2, 3. Base 2 is this entire thing here. That's 1, 2, 3, 4, 5, 6, 7. And then the height I can count because since these 2 lines are horizontal, well, the height has to go from one base to the other and be perpendicular. So the height is also 3. So that means I can easily count those dimensions I need and plug them right into my formula, and then I'm done. So I have 3 plus 7, doesn't matter which one you call base 1 and base 2, times the height, which is 3, all over 2. So I have 10 times 3 over 2. So I get 30 over 2, so I get 15 units squared. So that's one option. The other option, well, there's actually 2 more options. I'm going to show you the third option in a minute. But the other option, this one would have been easy enough to divide it up into shapes. So another scenario here is to, if like, let's say you forgot the trapezoid formula, right? And it's not on your formula sheet. What you could do, when I drew in this height here, you could probably see I created a right triangle. What I could do is break this up into shapes that I can easily find the area of. So this is called you're decomposing it. You're breaking it up into shapes, but I'm just going to say break trapezoid up into other shapes. So I'm going to say triangles and squares or rectangles. So what I can do is I have really 3 shapes here. So I have my 2 triangles. So I could have the area of the triangle is base times height over 2. So I know that I have a base of 1, 2, and then a height of 1, 2, 3. So 2 times 3 over 2. So this is just going to end up being 3. And then if I look at this square that was formed, it's a 3 by 3. So I have 3 times 3, which gives me 9, because area of a square is just length times width. So there's the total area would be adding the 2 triangles, because there was 2 triangles and they're both the same area, they're the same dimensions. So 3 plus 3, add those twice, plus the 9. And when you do this, 9 plus 6, you get the same answer. So that way is another way. It's a little bit longer, I think, in this problem. But for some people, it's easier. Instead of trying to think of the formula, well, just break it up. So that is always an option. You can break it up. into other shapes. You could always just count, like for area of a square, you could always count the boxes. It's just not as efficient, but it's possible. For a triangle, you could always make a rectangle out of it, find the area of that, divide it by 2, because remember, a triangle is half of a rectangle. So lots of options. The last one I want to talk about, though, is what happens when your measurements or your dimensions that you need aren't countable. So if you look at this picture, it's a quadrilateral. I can't easily count the base and the height of these. Plus, I don't really know if this is even a trapezoid. I know it's a quadrilateral, but it's definitely not a rectangle or square. There's no right angles, but I don't even know if these are parallel. So it might not even be a trapezoid. So the question becomes, how do you find the figure? How do you find something like this? So this is our third method, and this is when we're going to enclose. So what happens when our figure is none of the shapes we've used formulas for? So this is going to be what I'm going to call method 3, going off of that previous example. And this is going to be, we're going to enclose the shape and subtract off unwanted areas. So what we're going to do is we're going to take our straight edge and we're going to enclose it. So we're going to basically make a rectangle around it. So I'm going to make sure that each of these, let me grab a straight edge here. So I'm going to make sure that each of my segments goes through each of the vertices. So then I'm going to take, again, do the same thing. So I'm making, if you look, I'm extending this all the way out to that other vertex so that it incorporates the entire width of that quadrilateral. And then same thing, I'm making sure that each of the vertices is lying on this quadrilateral. And so this is the step where you're enclosing it. So you're enclosing it with a shape that's easy to be able to find measurements of. So now when I look at this, I can easily count the dimensions of this rectangle. So I can count this entire rectangle has a width or a height of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then this entire dimension is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So what I do know is I could find the area of the entire thing, and then what I'm wanting to have left is this area right here of this quadrilateral. So what I want to end up doing is find the area of this rectangle and then just subtract off these 4 right triangles. And the 4 right triangles are going to be easy to deal with because they're all right triangles. So I can easily find the areas of those. So what I'm going to do, step 1 here is going to be to find the area of the entire figure. So that's going to be a rectangle, length times width. So I'm going to do 13 times 14. So the area of that is going to be 182. And then what I need to do is I need to find the area of each of those triangles. So the formula is base times height over 2. So for the first triangle here, I'm just going to write area of triangle 1. I have a base of 1, 2, 3, 4, and then a height of 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be 4 times 9 over 2. And remember, it doesn't really matter the order here that you put the base and the height in. It doesn't make a difference. So I multiply that. I get 36 divided by 2, which is going to be 18. I'm going to just keep doing the same thing. So I'm going to do triangle 2, which is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is going to be 1, 2, 3, 4, 5, 6. So I have base times height over 2. So it's going to be 60 over 2, which will be 30. Then I have area of triangle 3. So this is 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. So 7 times 6 over 2. So this is going to end up being 21. So you could just do 6 divided by 2, you get 3. 7 times 3 is 21. And then the last one here, area of triangle 4. I'm always counting these dimensions too, even though you could, look at this if the whole thing's 14, this is 4, that's 10. I'm just counting to kind of double check the total measurement. So I have 1, 2, 3, 4, 5, 6, 7, 8. And again, 8 plus 6 should end up being the 14 that we said it was. And then if this is 9, well, this should be 1, 2, 3, 4. So that checks. So we have 8 times 4 over 2. So again, you could think of this as 8 times 2. So 16, because the 4 divides 2. 4 divided by 2 is 2. So there's all the unwanted areas. So this is the area, the total area. This is everything I don't want. So then for the third step, you just subtract. So the area of the quadrilateral, which is what you're trying to find, is going to be 182, the total area, minus the sum of all of these unwanted areas. So I'm just going to add these all up and subtract them. A couple different ways. You could individually subtract each number off. You can add them up first. So when I add them up first, I get 85. So essentially this is going to be 182 minus 85. So you end up with 97. So 97 units squared would be the area of that quadrilateral or the shaded region. So that's the strategy. So you really have 3 different strategies when you're on a grid to be able to solve these. So otherwise, you're going to start to see some more practice too with using the formulas in application problems and in plain space where you just have a picture to deal with. So go ahead, get your key ideas down and write and do your check your understanding problem.